Today is your lucky day because you get to learn a second equation for lines. And so this equation is going to be called, excuse me, standard form. And by the end of this video, you should be able to say that you're up on these three things. What the heck is standard form? Can I graph it by finding the x and y intercepts? And can I graph it by converting into y equals mx plus b slope-intercept form? Of course, you already know y equals mx plus b slope-intercept form. You could graph that thing like a pro. But what we're moving to is this new standard form, and you'll notice that this looks a heck of a lot different than that. And if you look at it in actual equation form, this standard form looks a heck of a lot different than that. This is solved for y, and this is not. Now, a couple of things from the math lawyers. For something to be truly in standard form, the 6 and the 2 and the 12, they should all be integers. So no fractions, no decimals. And technically, the a, the leading term, should be positive. No negatives out in front. Okay, so we're going to work on this standard form stuff and the rest of this video. So you now know how to identify standard form. Now let's see how we can graph it by finding the x and the y intercepts. So you look at this equation and you say, yep, that's definitely standard form. It's not solved for y, and it's something x plus something y equals a number. Okay, so if we're going to graph by x and y intercepts, we have to make sure that we truly understand what an x and a y intercept is. Aha, bring in this little picture. In this graph, I have an x-intercept right there because the green line intercepted the x-axis. That means this is the y-intercept. So you know all of this. So if I look at this graph, I have an x-intercept right there because the graph intercepts the x-axis, and a y-intercept right here. If I look at this nonlinear graph down below, I have a y-intercept here and an x-intercept here. So identifying those intercepts is pretty easy. But I want you to notice this thing. Every x-intercept on this page has a y value of 0. This x-intercept has x5, y0. This x-intercept has a y value of 0. This x-intercept has a y value of 0 in its coordinates. In fact, we can safely say this statement right here, every x-intercept in the entire world has a y value of 0. You should probably memorize that. And now we're going to notice a similar phenomenon with the y-intercepts. Here's a y-intercept. It has an x value of 0. Y-intercept, it has an x value of 0. Y-intercept, its x coordinate is 0. So as you would guess, we can come up with this statement. Every single y-intercept in the entire world has an x value of 0. These two statements you should probably memorize, but let's say your brain forgets it. Anytime you draw any graph and you put down the coordinates of the x and the y-intercept, you will see that the y-intercept has an x value of 0, the x-intercept has a y value of 0, and that's exactly what these statements are saying. So why was I talking about all that stuff? Here's why. We're trying to find a graph of this standard equation by finding the x and the y intercepts. And if I know the statement that every x-intercept in the entire world has a y value of 0, on this very primitive t-chart, I put a y equals 0 right there. And now what I can do is I can use that y equal, excuse me, I can use that y equals 0 to plug into my equation. And you see my work over here on the right. I took my equation and I said, okay, y is going to be 0, so I plugged in a y equals 0. I worked it out and I solved for x. Now I know the x-intercept. It's 6 for x, 0 for y, or I can think of that as the ordered pair 6, 0. I can use the same logic over here. Every y-intercept in the entire world has an x value of 0. So now I can just plug in the the x equals 0 into here and get a y. And there it is. I took my x equals 0, plugged it into my equation, and I get out a y equals 3, which means the y-intercept is 0, 3. I've now figured out the x-intercept and the y-intercept, so now I can graph them. Watch how easy this is. I've made a very crude coordinate grid. My x-intercept is 6, 0. So I just put a dot right there at 6, 0. There's my y-intercept, 0, 3. I have my x-intercept and my y-intercept. I draw a line between the two, and I have just graphed that equation by using the intercepts. Here's another example of an equation in standard form that we can graph by intercepts. I suggest that you pause the video and you see if you can do it yourself, because watching someone else do it doesn't mean you know how to do it, but doing it yourself does. And I'm going to pause this and work this out. So in about 4 seconds on the video, you will see all my work. Hopefully you have done it yourself and we can compare. Okay, so I started with my t-chart. The x-intercept has a y value of 0. By working through there, I got out an x of -2. Every y-intercept has an x value of 0. By working through there, I got out a y value of 6. So there is my x-intercept, there's my y-intercept. I'm going to put them on the graph. There's the x-intercept right on the x-axis. Here's the y-intercept right on the y-axis. And here is my graph by graphing by intercepts. If I wanted to label the intercepts, I just have. So that is graphing by intercepts. So remember when we started the video, we had 3 goals. Can you identify standard form? Yep. Can you graph by finding the x and y intercepts? Yep. And we're going to end by doing the same graphing but converting into y equals mx plus b. This is the same equation we did on the other example when we graphed by intercepts, but now I'm going to graph by converting into y equals mx plus b, which is as simple as taking that equation and solving for y. Do you remember your teacher earlier in the year stressing solving for y? This is why. So can I take this standard form equation and get y by itself? Heck yeah. I need to move the 5x over, then get rid of the 10. I'm going to pause and then show my work. Okay, I moved the 5x to the other side, then I divided each side by 10. I have y by itself, but it's not looking like this form yet, and this is the part that gets people. This 10 in the denominator has to kind of divide or reduce with both of those terms. So what I'm really thinking here is some version of this plus this. Now that seems weird, but that 10 divides into both of those terms, so you might want to write it out like that. And I'm going to go one more step. The 5 over 10 reduces to 1/2. The 30 divided by 10 reduces to 3. So now I have converted into y equals mx plus b form, even though I started in standard form, and it would be really easy to graph this. I take this equation, that's my y-intercept. That's the first dot that goes on the paper. The slope is down 1 over 2, down 1, right 2, down 1, right 2, down 1, right 2. And I can keep that trend up, but there is my graph of that equation by converting into slope-intercept form. By the way, when we graph that equation using x and y intercepts, we got the same looking equation, different method. Okay, last problem. We're going to graph by converting into y equals mx plus b. This is also the same equation we did previously by graphing by finding x and y intercepts. So we need to solve for y and then graph it. You should try out your steps and then compare it to mine by pausing the video, because you'll notice we have negatives in here and students end up with troubles with negatives. Okay, a couple tricky things. First of all, can you get y by itself and match what I have? you've got some negative issues going on in there, so you have to be really careful. Then when you graph this, the y-intercept is 6, but the slope is 3. Now I have to remember that that slope can be thought of as rise over run like that, or rise over run like that. If I choose this one, that means I have to rise 1, 2, 3, run of positive 1, and another dot would be there. Up 2, 3, over 1, and another dot would be there. Or I could think of it like this, rise of negative 3, 1, 2, 3, run of negative 1, 1, 2, 3, negative 1. No matter which way I choose, I end up on the same path. So there's my graph, and it should be no surprise that when we did this equation with finding x and y intercepts, we got the same looking graph as we have by solving for y. Okay, there was a lot of information on this video. These are the 3 items you need to be expert at after you practice your homework.